Okay, so we're going to start with our revision for chapter 2, linear motion. So the first thing that is important in chapter 2 is the ticker tape calculation. Usually ticker tape has a frequency of 50 hertz. So how many seconds for 50 hertz? 50 hertz means that 50 dots per second. So 1 dot equal to 1 over 50, 0.02 second. So that is the time needed for 1 dot to produce 1 dot in the ticker tape. So usually the things that they ask for ticker tape is displacement, initial velocity, final velocity, and acceleration. So the acceleration is the last thing that we need to find. So that before that, we have to find the displacement, the time, the initial velocity, and the final velocity. So the initial velocity can be determined by looking at the arrow. So the arrow shows the direction of motion for the trolley attached to the ticker tape. So if the arrow stated here, shown here, that means this is the first step, the first dot, the first tick. So we can say that this is the initial velocity between the two ticks, the two dots. And the last one, the last two is the final velocity. So to find the initial velocity, we have the formula displacement over time. So what we need to do, we just plug in the value of 0.2 cm and then the time taken for one tick, which is the distance, the time taken between the two dots, which is 0.02 seconds. Then we plug in that into the calculator. We will get 10 cm as -1. So that's the unit for velocity, initial velocity. So same for the final velocity. Now we have to plug in 0.8 cm divided by 0.2 second. So we will get 40 cm as -1. So we basically already find the initial velocity and the final velocity. So now we have to look at the formula for acceleration, which is A equal to V minus U divided by P. So we have the V, the value of V, the value of U, but we don't have the value of P, which is the time taken. The time taken between the initial velocity and the final velocity. So how we want to calculate that? We have to find the number of jumps between the two U and V. So this is represented by 1 jump, 2 jump, and 3 jump. So basically, we have 3 jump, and each jump represented by 0.02 second. So we have, this is the value of E. 3 times 0.02 is 0.06 second. Now we have all the values in order to find the acceleration, we just plug in the values. So 40 minus 10 divided by 0.06, we get 500. 500 cm as -2. This is the unit for acceleration. So we see that it's accelerate because the dots, the distance between the two dots is keep increasing. So it means that it's accelerating. The velocity is increasing, so it's accelerating. So let's look at the next question. Same with a ticker tape, but now we divided the parts of the ticker tape differently. Before this, we just use the distance between the two dots to calculate the initial and final velocity. Now we have to use several dots to calculate the initial and final velocity. So let's see how many dots here between A, B, B, C, C, D, and D, E. I bet there must be a same number of dots. Otherwise, we cannot calculate it accurately. So let's count 1, 2, 3, 4, 5. So there's 5 dots between AB. So let's see about BC. 1, 2, 3, 4, 5. Also 5. And CD also 5. And lastly, DE is also 5. So that means that the ticker tape is divided evenly by 5 dots. So let's see the question number A. Calculate velocity at AB and DE. So AB here and DE here. So the direction of motion means that AB is the initial velocity, DE is the final velocity. So that means we have to calculate the initial and final velocity. So A, initial velocity S over T 2 cm divided by 5 dots times 0.02 seconds. So we get 0.02 20 cm as negative 1. So B S over T 8 cm divided by 5 times 0.02 second. 80 cm as negative 1. So now we move on to B. Calculate the time interval between the velocity AB and DE, which is between the initial and final velocity. Same like before, we have to calculate the number of jump. So 1 jump, 2 jump, and 3 jump. So 3 times 5 dots per jump and 1 dot 0.02 seconds. So is this the T? So we will get 0.3 seconds. Okay, so we have all the information needed to calculate the acceleration. We have the initial velocity, final velocity, and the time taken. So we just plug in into the formula. So V is 80 minus 20 divided by 0.3. Minus 20 divided by 0.3, we get 200. The unit is cm as negative 2. Okay, so that's question number 2. Let's see question number 3. So in question number 3, there is no arrow to indicate the direction of motion of the ticker tape. So we just assume the same direction as before. So that means that this is the U, the initial velocity, and the final 2 is the final velocity. So same, we have to find the U, but now we have to determine the number of dots for each section, and I bet they're all the same. So let's see here, because it is more clearer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is 10 dots per section. So 10 dots. Keep that in your mind. So S over T, 4.0 cm. We have 10 dots. S times 0.02 second. S times 0.02 second. So we plug in that into the calculator. 10 times 0.02, we got 20 cm as negative 1. So final velocity 12.4 cm divided by 10 times 0.02 second. 0.02 second, we get 62 cm as negative 1. So time taken between the final and initial: 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump, 7 jump. 7 jump, each jump have 10 dots. Each dot has 0.02 second, 1.4 second. So we plug in into the formula v minus u over t, 62 minus 20 divided by 1.4, divided by 1.4, we got 30 cm as negative 2. That's the acceleration for the ticket number 3. Okay, so let's move on to the next question. This is about the graph, ticket graph. Basically, each ticket, each section of ticket has the same number of dots for each of them. So if you look at the last one, we can determine the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, it's just 10 like before. So in order to find the acceleration for the ticket, we have to label the u and v. So the first one is u, the last one is v. And then this one, this side here is the displacement. Okay, the displacement. And then this is the time, usually the time. Okay, so let's find out the u. So u equal to s over t. U is 2 cm. Oh, the s for u is 2 cm. And then we have 10 dots. Each dot has 0.02 second. Okay, plug in that into the calculator. 02, we got 10 cm. 10 cm as negative 1. So how about v? Still the same formula. Now we have 12 cm. 12 cm, 10 dots, 0.02 second. But into calculator, we got 60 cm as negative 1. So how about the time taken between the u and the v? Calculate the number of jumps. So 1 jump, 2 jump, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So 10 jump times 10 times 0.02 second. 2 seconds. Okay. So plugging that into the formula. V is 60. U is 10 divided by 2. Divided by 2 seconds. So the answer 25 cm as negative 2. Okay. So if the graph is increasing like this, linearly increasing, that means it's accelerating, positive acceleration. If the graph decreasing in length, that means that it's decelerating, negative acceleration. Okay, let's see the number 5. Question number 5, calculate the acceleration of the ticket graph below. So let's see how many dots this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still 10 dots per ticket. So this is U and the final one is B. So find U first. S over T 0.5. So we don't have any unit here, but we assume it's centimeter. 0.5 cm divided by 10 times 0.10 times 0.02 second times 0.02, 2.5 cm as negative 1. So V S over T. So now the S is 4.0 cm divided by 10 times 0.02 second. 20. cm as -1. So let's determine the time taken. Calculate the number of jump. 1, 2, 3, 4, 5. So 5 jump, each jump have 10 dots. Each dot has 0.02 second. So 1 second. So calculate using the formula for acceleration. V is 20, U is 2.5 divided by 1. 20 minus 2.5 is 17.5. 17.5 cm as -2. So that's the effective calculation. It's very easy if you remember the steps. Remember the differences between the ticker tape graph and the single ticker tape like this, which is only divided by the dots between the two dots. But this divided by the same number of dots. That means each section has the same number of dots that you have to calculate. And then to calculate that, to find the acceleration, to determine the acceleration, the time taken, you have to find the number of jumps. Number of jumps between the U and V. As simple as that. Okay, let's see the next section, which is the linear motion equation. So remember that we have four types of linear motion equation. The first one is the acceleration. U, well not U, V. V equal to U plus AT. Next, S equal to 1/2 U plus V times T. Next is the V square equal to U square plus 2AS. And the final one is S equal to UT plus 1/2 AT square. So we have four equations, and each equation used in different situation. So for example, the number one, we don't have S. So make sure that the problem is if there is no displacement stated and no need to find the displacement, then we can use the number one. Number of two, we don't have acceleration. So same case, if we don't have acceleration stated in the question and that the question also don't ask for acceleration, then we can use number two. So this is number one, number two. Number three, we don't have P. So in this case, no time needed. Number four, we don't have V. So no final velocity is needed. So let's see the question. A car accelerates at 5 ms-2 from rest. So based on the first sentence, we can extract the information, which is A equal to 5 ms-2. From rest means that the initial velocity is 0. From means that the start, from the start, which is the initial velocity. At rest means that there is no movement, so no velocity or zero velocity. Find its velocity after 8 seconds. So t equal to 8 seconds. Find the final velocity after. After means final. So we don't have what variables here. We don't have s. So no s. So which equation that don't have s? Equation number one. So let's rewrite the equation, and then we need to find v here, so we don't need to rearrange, just plug in like usual. So u, the value is 0, a is 5, t is 8, so we get 40 cm as -1. Okay, so next, the bicycle moves at constant velocity. constant velocity, 5 meter per second. So we can make it v, then 5 ms negative 1. The bicycle accelerates until its velocity 25. So accelerates, that means this is not v, this is u. Then it becomes the final velocity 25 ms negative 1 within 40 seconds. So that's the time. 40 seconds. Calculate the displacement s equal to what? Traveled by the cyclist. So we don't have a this time, acceleration. There is no acceleration values given, even though there is word accelerates there, but we don't need that words to calculate. So it just give you the hint that which one is initial velocity, which one is the final velocity. So in this case, we have to use the equation number 2. S equal to 1/2 u plus v times t. So we need to find the displacement. So no need to rearrange the equation. We just plug in like usual. 25 and then 40. Then we get v divided to 600 meter for displacement. Okay. Number 3. Due to a short airport runway, a plane must achieve its final velocity v. This is stated clearly, the final velocity. So it's symbol v, ms negative 1, 200 ms negative 1, from rest. That means that the initial velocity is 0. Within distance, 500 meters. So distance also same as displacement in this case. Calculate time taken t. In this case, we don't have a. So same formula as above. S equal to 1/2 u plus v times t. But we need to calculate t. That means that we have to rearrange the equation first before we plug in. So the 2 must come here, become multiplication, 2s u plus v times t, and then the whole thing here must come here, become division. 2s divided by u plus v equal to t, and then we can plug in the values. 500, u is 200, or u is 0, v is 200. 500 times 2 divided by 200. 5 seconds. 5 seconds. Okay. The next one. A car moves from rest. Okay, from rest, that means initial velocity is 0. Accelerate constantly with 0.2 meter ms negative 2. So that's A. 2 ms negative 2 in 5 seconds. T. 5 seconds. Calculate distance as. So this time we don't have the value of v. The value of final velocity. No v. So the what kind of equation that we have to use? We have to use number 4. S equal to ut plus 1/2 at squared. So since we need to find the distance traveled, which is the s, same as displacement, we don't need to rearrange the formula. Just plug in as usual. So time is 5, 1/2, 2, 5. So A is 2, 5 square. So make sure that you put the square here so that you can do not forget to plug in that into the calculator. Get 25 meters. Okay, let's see the next question. Free fall. Okay, free fall basically use the same fall equation as before, but we only use instead of four, sorry, we use three only. The equation number two is not used because we don't have the value for acceleration. So in order to solve problem involving free fall, we need the value of acceleration. So number one, number three, and number four equation all have the a there, the acceleration there. Okay, so free fall, the value of gravitational acceleration is negative 9.81 ms negative 2. Okay, negative sign means that the direction of acceleration is always downward to the center of the Earth. So G, 9.81 ms negative 2. Okay, that's the value of G. Okay, so we have to make a sign convention here. If the object moving downward means that free fall, then the value of G is positive. If it's moving upwards, then the value will be negative because when the object moving upward is slowing down, this means that's decelerating. So the acceleration value must have negative sign. While the free fall is keep accelerating toward the center of the Earth, so the value of acceleration should be positive, even though the direction is actually negative, but it cancels out, it's become positive. So let's see question number one. Ahmad released the wooden block from top of the building. Okay, this is from top to bottom. That means the G is positive. Falling down, free fall. If the block takes 4.4 seconds, so that is the time to reach the ground, calculate the height. So we all have another one, 9.81. So we must have one more variables in order to solve this question. So we pick that, we assume that the wooden blocks fall from rest, which is 0. Okay, so we have all the four variables that we can solve using one of the linear motion equation. In this case, we don't have V, so we use the fourth equation, S equal to UP plus 1/2 G P square. So replace the A with G. So since we want to calculate the height of the building, which is the displacement actually, so we just need to plug in as usual. Plus 1/2, 9.81. The time 4.4. Don't forget to put the square in the calculator. 0.5 times 9.81 times 4.4 square. Okay, 94.96 meter. Okay. Next, a stone is released into a well, so it's still top to bottom, which is free fall. G equal to 9.81 positive value. To determine the depth of the well, so S. We need to determine the S. Stone reach the ground after 2 seconds. T. 2 seconds, calculate the depth. Again, we assume that the initial velocity is 0. Assume that the stone released from rest and then into the well. So same formula, same equation. You don't need to rearrange. 0 times 2, 1/2, 9.81, 2 square. So we get 2 square, 19.62 meters. Okay, next. A ball hits by baseball bat upward. Okay, this one upward. Okay, from bottom to up, the value of G is negative because it's slowing down. With velocity 20 ms negative 1. So this is the initial velocity because the final velocity should be 0 when it reaches the maximum height and then fall back at free fall. So calculate the maximum height as achieved by the ball. So we need one more variable which is v, the final velocity which is 0. Because when the final velocity reaches 0, that means it's at final height, at the not final height, the maximum height. So if we draw a quadratic curve, so the ball should be start here, and then we will move upwards until it stops instantaneously here. So this is V, stop instantaneously when it reach maximum height before it fall back again towards the center of the earth. Okay, so in this case, we don't have time. So let's see which equation that should we use. I think equation number 3. Let's see. Yes, equation number 3. We have to use the equation number 3, replace A with G. Okay, V square equal to U square plus 2GS. So we need to find S. So rearrange V square minus U square divided by 2G. So plug in 0 square minus 20 square divided by 2 minus 981. So S equal to divide. We got 20.39 meter. Okay, that is the maximum height achieved by the ball when it reached velocity 0 before it falls back to the ground. Okay, the final problem for today. A rifle shot with speed of bullets 20 meters per second toward a bird with height 40 meters. That means it's moving upwards. And then we assume that the bullet here, the rifle, and then the bird here. So we have the bullet hits the bird. So this is the initial velocity. 25 ms negative 1 towards a bird with height s equal to 40 meters. This the bullet can hit the bird. Okay, that means we need to find the maximum height when the final velocity is 0. And then G is negative 9.81 ms negative 2. Okay, so note equation number 3, V square equal to U square plus 2GS. Okay. Now we need to find S. We rearrange S. This is the height of the bird, not the height of the bullet. So we need to find the height of the bullet and make sure to check that the height of the bullet at least 40. So that's the goal. So V square minus U square divided by 2G, 0 square, V of 0 minus 25 square, 2 negative 9.89. So S is negative 25 square by 2 divided by 9.81. We got 31.86 meter. Since the height of the bullet is less than 40, so the bullet cannot reach the bird. So that's the conclusion here. Cannot reach the bullet. Can reach the bird. Okay, that's all for today. Let's see you again soon. Thank you.